everyone. Now I am going to discuss about types of standard solutions. So standard solution means that is something their concentration is known. So there are two types of standard chemicals. When we dissolve those chemicals, we get the standard solutions. Okay. So the first types are primary standard chemicals. So what are primary standard chemicals? The chemical substances which must be pure, which means it should not contain any other impurities. Okay, so only particular chemical composition. For example, calcium carbonate means it should contain calcium carbonate. I am not telling that is a primary standard. So chemical should be very pure and it should be stable at the room temperature. Suppose if I open it in the lab, it should long last. It should not get moisture and it get absorbed, and it should not get any other reactions in presence of the moisture, or in presence of the temperature it should not degrade. So it should be stable at the room temperature and the atmospheric conditions, and it should not be hygroscopic or non-hygroscopic. What is hygroscopic means? So when you keep the substance, what happens? It absorbs the water and becomes kind of liquid or kind of delicescent. Okay, when you touch it, it will become like a oily kind of thing. So like the solid state can be converted into the kind of liquid state, or kind of amorphous, like a solid plus solid kind of. It will have moisture. So that's the thing is, when it absorbs the water molecule, so the phase will change. Okay, it won't be in the solid state, it will go into the intermediate phase, like a solid and liquid mixed phase. Okay, so that is called hygroscopic. And when we have high molecular weight, we can prevent the errors in the calculation. Okay, so that's why we use mostly ferrous ammonium sulfate in the redox titration in order to avoid the errors. Okay, so we calculate in volumetry, we end up with errors. No, even when we are changing even 0.1 ml, it can make a lot amount of error. So if you have the primary substance, chemical substance, when it has high molecularity, it can minimize the errors. Okay, and accurate strength can be known. For example, if I take 1 mole means like if I weigh for example oxalic acid, I can take 63 gram of oxalic acid. When I dissolve it in 1 liter standard measuring flask, I can get the 1 normality of the oxalic acid solution. So I can keep it for even a month. Okay, it won't change its concentration. Suppose if I am making like 1 molar concentration of HCl or sodium hydroxide, what happens? HCl immediately the vapors will go out. The whatever the concentration you prepared today, that won't be same for tomorrow. So the accurate concentration, when we prepare, it will long last. So the concentration will be known. Okay, and so when we know the concentration of this primary standard chemical, we can find out the concentration for the some unknown chemicals, especially for the secondary standard chemicals. So these are the properties of primary standard chemicals. So they are pure, they are stable, and they are non-hygroscopic. They have high molecular weight, and their strength is known. They use to calculate the strength of the other unknown solutions. Okay. So then what is secondary standard chemicals? So the chemicals which do not follow any one of the above property, we call them as a secondary standard chemicals. Okay, their strength is unknown. Even if you prepare their strength, tomorrow it won't have the same concentration. Okay, so they will change depending upon the time. Okay, so that's they will be hygroscopic. They might take water molecules, or when you keep it in the temperature, it will change, or they will catch fire. So those substances we have to be very careful. So but for the time being, when you are doing titration for that day, by using the primary standard chemicals, we can find out the concentration of the secondary standard chemicals. Okay, so what are the examples for the primary standard chemical? Oxalic acid. So we can just open it, it will be in the solid state, and we can just weigh it in the chemical balance or in the electronic balance, and we can dissolve it in the standard measuring flask, and we can prepare the known. Similarly, ferrous ammonium sulfate, potassium dichromate, and etc. The secondary standard chemicals, they will not follow the above conditions. For example, HCl, NaOH, calcium carbonate. So what happens, HCl in industry itself, what they do is they'll just dissolve the HCl gas in the water. So when you open the lid, the fumes will be coming out, right? You could have seen in your lab. Even NaOH, what happens, even if it is the solid state, when you open up and keep the pellets for 2-3 minutes, it will catch, like it will absorb the atmospheric water and becomes delicescent or hygroscopic in nature. So these substances, their strength can be measured using the help of the primary standard chemical. In your book, they are given as a standards and working standard. So this is in detail. When you come to the higher studies, we use a primary standard chemicals and a secondary standard chemicals. So you are primary standard, using the primary standard, you just find out the concentration of the other primary standard or other secondary standard solutions. Hope you understood this one. So now let us move on to the factors which affects the solubility. So what are the factors which affect the solubility? So the first factor is nature of the solute and solvent. For example, sodium chloride will be soluble in water. So sodium chloride in water, and I am taking camphor in kerosene. Okay. So sodium chloride is a polar substance and water is a polar solvent. So polar substance will be soluble in the polar solvents. Camphor is what you call it is a organic compound, and kerosene is an organic solvent. It is soluble in the soap. Like a polar substance will be soluble in the polar solvents. Similarly, non-polar substances are soluble in the non-polar solvents. So if you change in other way, it won't last. Okay. The second one is effect of temperature. Here, depending upon the phase, say a solid solute in liquid solvent and gas solute in liquid solvent. So when you increase the temperature, the solid solute is more soluble by increasing the temperature. Okay. But in the case of gas solute, when you increase the temperature, it is the solubility decreases by increasing the temperature. So similarly, effect of pressure, it is only applicable for gas solute in liquid solvent. When you increase the pressure, solubility increases. Okay. So these are the three factors. In your book, they are given with the even a little more diagram for few substances. You can refer that. Hope you understood this one. So, thank you.